Okay, we have here today another interesting integral. This one's from Swinbee 2018, problem 17. We have the integral of x squared minus 3x plus 2 over x plus 1 cubed dx. Okay, now at first I was trying to factor it, but it didn't seem to really help me out very much. And what I found was we could just do partial fractions on this and it's not too bad. So let's just set up the partial fractions for this. So now for partial fractions, this is going to actually be the repeat case. We just have like one thing here cubed. So we just build up the powers. We'll take this first one, we'll have x plus 1 to the first power, then we go to the second power, then the third power. But the nice thing about this is the numerators are just all constant values. We don't have to do like an ax plus b here because the power of x plus 1 is just to the first power, so it keeps it pretty simple this way. And now I could use the cover-up method in order to get my c value, but we're going to have to do some extra work anyway, so I think I'm just going to kind of do it the long way. And what I'll do is I'll multiply this equation. We'll multiply both sides by x plus 1 cubed, multiplying it through on the right side here. So that what happens is on the left side, this is going to cancel here. Then I'll distribute this into each term. So like for the first part, we'll have a, but like x plus 1 is going to cancel with one of these. So we're going to have a times x plus 1 squared. And then for this one, two of these is going to cancel with two of these. So we're going to have b times x plus 1. And then the last one, we're just going to leave. And then for the last one, x plus 1 cubed will cancel with x plus 1 cubed. So this is going to be just c, and we'll copy down this part here. And then I can just distribute everything out here and multiply it out. So this is going to be here. We'll have ax squared plus 2ax plus a. Then distributing in the b, we'll just have bx plus b plus c equals the right side. So then here, in order to solve for a, b, and c, I can get my like terms and separate out like the square terms, the first degree terms, and the constant terms. So first for the x squared term, we'll have ax squared is equal to just x squared here. Then I can gather the first degree terms. So for this, we're going to have 2a plus b. This is all our x terms, and then on the left side, and on the right side, we'll have minus 3x. And then we'll just gather our constant terms. So we're going to have just a plus b plus c. So we're saying a plus b plus c is this thing, which is just 2. Now for our first equation, if ax squared, this is just equal to 1x squared. So we're saying, we can say that a equals 1. But then we can take that and we can plug it back into this second equation. So plugging 1 in here, we end up with 2 plus b all times x equals minus 3x. We don't have to worry about the x's, we're just solving for b. But then here we can subtract 2 on both sides and we get b equal to minus 5. And so then we have our a and b value, we'll just plug it into the last equation. Here we're going to have 1 minus 5 plus c equals 2. But then just solving for c, we find that c equals 6. So coming back over here, we know our a value is 1, our b value is minus 5, our c value is 6. So all we need to do now is just take all this stuff and put it back into the integral and finish it off. Next, now that we have our constant values in the numerator, we can just do 3 pretty easy integrals in order to finish this. So for this first one, this is actually going to be just natural log absolute value x minus 1. Now here for this one, you could do a u substitution, but we don't need to because the derivative of the inside here, if I make my u this, it's just going to be 1 dx. So what I can do is actually just kind of do power rule on the fly. If I just rewrite this, we'll bring it into the numerator and write it as minus 5 x plus 1 to the minus 2. Then just doing power rule on this, we have minus 5. We'll have x plus 1 to the minus 1, but then we need a minus 1 here in the denominator. We'll come back and clean it up in a second. And then we can do the same kind of thing here, writing this as 6 times x plus 1 to the minus 3, and just using power rule again. So this is going to become plus 6 x plus 1 to the minus 2 over minus 2. And then we can just do some simplification. Let's copy this stuff down right here. Now here, minus and minus gives me a plus. I can write this as 5 over x plus 1. And then here, 6 over minus 2 gives me a minus 3 in front. Then I can write x plus 1 minus 2 as in the denominator as x plus 1 squared. But then I can get a common denominator here, just multiplying by x plus 1 over x plus 1. And so let's see if we can just put everything together. So we're going to have natural log x minus 1. Then here we'll distribute in this 5 here. The denominator I can write as x plus 1 squared. And then the numerator we're going to get 5x plus 5 minus 3. So I'm just going to write that as plus 2. Give it a plus c, and that's it. Okay, so there you have it. Good one from Swinbee 2018. Thanks everyone for watching. Have a good day.